Finding the formula for the area of a circle, you know what it is. It's pi r squared. Is a little trickier just visually in terms of this. So I'm going to try and create a little environment to make sense of this. So just pay attention. I'm going to take a circle and cut it into 4 quarters and kind of put those 4 quarters back to make this shape. Now the truth is that shape doesn't look like anything you really recognize. But I will tell you it's going to get close to something you will recognize. So let's bring in a different version of that. If I took that same circle but divided it by 8 portions, right, 8 portions, and put them back to back, I think we're starting to make a shape maybe kind of like something you might recognize. Some of us might say that's a caterpillar. I don't know. But anyways, maybe we're making something that is more like a shape we recognize. Maybe not. Let's bring in another one. Let's divide it up into, I don't know, is this 12? 1, 2, 3, 4, yeah, 12. And again, would you say that you are seeing kind of a shape maybe? A little bit like what you might recognize. Maybe not, I don't know. How about if we cut it up even into more pieces like this one? And now I think you're starting to see, wait a minute, look at that. I actually recognize that shape. This is called kind of like a limit argument, which means as I'm cutting it smaller and smaller and smaller, it's like approaching something that I might recognize and be able to work with. So if we take these out for just a second here, and we bring in maybe this, again, this movement process here, what I want you to notice is that, again, when we cut it into 4, so that was no good, and then 8 was better, and then 12 and 16. Now you're starting to see a parallelogram form, aren't you? And let's learn a little bit about the parallelograms information. So how far is it from one side to the other? Well, it would just be pi it would be pi r. Why would it be pi r? Well, 2 pi r is the entire circumference of the circle. But you'll notice we're only looking at half of the circle. The other half is up here. The little bumps are along here. So this is only half of it. So this dimension is 2 pi r, just pi r. Now, what would be the height of our parallelogram? You can see it there. R is our height, isn't it? Now, here's the so cool thing. If you multiply our value of pi r times r, what do you get? You get pi r squared is the area of that parallelogram. And that parallelogram, where did it come from? It came from a circle. And so the finer and finer and finer we cut up our pieces, the closer and closer we get to that beautiful pi r squared. That's a very cool way to see it or understand. Let me show you kind of by animation now. So here's the same argument, but just kind of in an animation. There's our 4 pieces, and it makes this funny looking shape that's not really anything like a rectangle. If we go out to 8, you see the gaps and spaces being much smaller. It's looking more and more, in this case, like a rectangle. If I went out to 12, see how it's filling it in nicely, and it's getting closer and closer to that perfect area. And ultimately, I'm at 12 here, but I could divide this up into a lot more, right? Like 14 or 16 or 18. And as I keep going, you can see the gaps get smaller and smaller. This is a limit argument that the dimensions would be pi r times r, which is pi r squared. Very cool stuff, isn't it? So obviously, a circle's formula is pi r squared, and that deals with all things that are full circles. Now, what a sector of a circle is it's like a piece or a portion of that circle. So in this first case, you can see that we're only interested in basically half of that. And there's no trick to that. That's just half of pi r squared. And if you notice this one, this is a fourth, and that's a fourth of pi r squared. Where it gets a little more interesting is what happens if it's a 49-degree angle. That's not a half or a fourth or a fifth or anything like that. But all you do is set it up as a proportion, right? Or as a ratio, 49 out of 360, because that is the percentage of the entire circle. Or for any value that's there, it's just x over 360 times pi r squared. So all you do is create kind of a percentage of the full circle when you do a circle sector. Let's solve a few now. So this first one is just a full circle, so it's simple, isn't it? It's just pi r squared. Our guy is a 4, which is the radius squared. And we just say 16 pi centimeters squared. Yes, you can turn that into a decimal, but no need to. Here, I want you to notice that I do not have a full circle, but I have 120 out of 360 pi r squared. Now that happens to be 1/3. Let's simplify it down. And if we multiply all of that mess out, we get 27 pi centimeters squared. And again, by doing this percentage here, I'm only calculating this region, 1/3 of our circle. Now here we have a 30 degrees, so this would be area equals 30 out of 360 pi r squared. Again, that is 1/12, I believe, pi r squared. And that actually simplifies nicely just to 12 pi centimeters squared. Again, you can put all that into a calculator using your pi key, but I don't feel a need to at this stage. Let's go to our next guy. I can see two things. I can see a half circle, and I can see a trapezoid. And so in doing so, let's calculate that out. The trapezoid would be 1/2 the height, which would be 3. The one base would be a 5, and the other base would be a 5, and a 5 would be 10. And I'm going to add that to a half of a circle, which is half of pi r squared, right? And so let's figure these out. This turns out to be 22.5. And this turns out to be 12.5 pi. And so the area of this shape are those two things added together. In an exact form or answer, this would be it. And as a decimal, we would get 61.77 centimeters squared. Kind of a fun one. So again, the key is kind of see it as the two pieces. I see the trapezoid here, and then I see the half circle here. And just make sure you took that into account. Let's do two final questions. Let's see. You can see what this is. This is 3 1/2 circles, right? 1/2 pi r squared. So just to make sure you saw what I did there. 3 of them, right? 1, 2, 3 of them. And don't forget that they are only half circles, not full circles. And that will turn out to be quite nice, actually, won't that? That'll be, I think, 13.5 pi centimeters squared. And then it's just a square, isn't it? Which is just 6 times 6 plus the 13.5 pi. Now, all of that is 36 plus 13.5, but let's just do a quick calculation here on the fly to get a decimal equivalent. That is approximately 78.41 centimeters squared. The next one will be a square, a 10 by 10 square. You see it. it will be a triangle. Actually, we could do this as a trapezoid. I'm already started it this way. Let's keep going, though. 7 times 10 divided by 2. And then I'm going to subtract a circle, a full circle, which is pi r squared. And again, how do I know these values? Well, again, this is a square of 10 by 10, making radius of 5. So we get 100 minus 35, or plus 35, what am I saying? Minus 25 pi. So we get 135 minus 25 pi. And again, we can go to an approximation of that. Let me just quickly get that in the old calculator. That's approximately 56.46 centimeters squared. This is the exact answer, and this becomes our approximate decimal answer to 2 places.